All right, Lancers, let's see how you did. Hopefully you were bold and gave these ray diagrams on page 77 a try. Let's see how you did. What we want to do again, I'm going to draw these a little quicker than I hope you did because I want yours to be really to scale because we're going to actually do something with the sizes and locations of the images. Um, um, so, um, but they should roughly look like what I'm going to draw here, and I'll try to make the quality actually high enough where it's really exactly how it should turn out. So what we want to do again, this first one is really an example or a case that we've looked at before. One little pro tip about how to be careful here is that first light ray that comes in, we want it to be parallel to the axis. So one way to ensure that is to actually just make a little dot here that is the it'll make this location here the same distance away from the line as that location there, and that's going to ensure that the line's parallel. And so then what you can do, and you can see I'm just using a cardboard straight edge. Hopefully this is good enough. What we're going to do is bring that light ray into the lens. Once you're in the lens, that light ray will converge because this is one of those lenses that's fatter in the middle. Again, you can do the little marching band theory thing where the light ray, the rows of marchers coming in, and this bottom part of the row will hit the slow material first, so it's going to get kicked down. So what you want to do is converge that light ray through the focal point. So let's do that. Boom. So there's our first light ray. Okay, first principal light ray. The second light ray that you can draw is one that just goes through the center of the lens undisturbed. So we'll do that. So we'll line that point up with the center. Let's get the thing lined up the right way. Whoops, there we go. So we're going to go from the tip of the arrow through the center of the lens, and you'll see it does actually meet up with that light ray over here on the other side. So you can tell already that we're going to get that. We've actually already done this case, but we're going to get a real inverted image at this location. So in fact, I can draw it in. I really should use my straight edge, but let's go for it. So this is a real inverted image. It's real because the light actually goes to that location, and that's inverted just because its orientation is opposite of what you started with. A third light ray that you can use would actually be one that goes from the top of the object through the focal point, and then into the center of the lens. So one that would come down like this to there. And then that light ray should then bend parallel to the optic axis. Looks like my drawing could be of slightly higher quality. Let's see. It more or less does meet there. So so again, you can see all those rays meeting at that location where the real inverted image is formed. Okay, so that was the first case. It should look something like that. Again, highly encourage you to use pencil. I'm just using pen because it shows up a little better for these videos. Next one, let's go a little quicker again because we've already done this one. You have a light ray, comes in parallel to the optic axis, like this. Whoops, I went a little far. That's okay. Goes to the middle of the lens. This is a diverging lens, so that light ray is going to take off. Now, how do we know how hard to diverge it? Does it diverge a little bit or a lot? The way that you know is it's defined by these focal points. So you have a focal point here that you can use as a guide to let you know how hard that ray is going to bend up. So it's going to bend as though it came from that focal point. So it doesn't actually come from the focal point. It just bends up along that line as though it did. So there's one light ray. The other light ray, as we mentioned before, just is one that goes from the top of the object through the center of the lens. So what I like to do is make a little dot, line this up so that you're lined up very well with the top of the object. and that light ray will come from the top of the object and then go unimpeded through the center of the lens. So you get this. Now what you notice is these two outgoing rays are not going to meet, and so you're not going to get an image over here like we did in the case above. And so what's going to happen is like, well, those light rays aren't going to meet, but they appear to be originating from back here. So you get this teeny tiny upright virtual image back here. Right. Virtual image. Okay, so that's the second case. Now let's move on to the ones that you have not seen yet. So again, just to recap, there's your top one. There's the first two. So take a look at that. And let's go down to these last two. You haven't seen these yet, but you'll see if you just follow the pattern, you'll be okay. So, you know, it's like, okay, we haven't done this exact case before, but how did we start? Well, we brought a light ray in parallel to the optic axis. So there we go. This is a converging lens, so we need to converge it. Well, how do we know how hard to converge it? Well, there's the focal points right there. So we're going to bend it down through that focal point. So there's your first light ray. Second light ray that we always drew, think about it for a second. Right? We've been drawing one that goes unimpeded through the center of the lens. So here's the center of the lens. So what we want to do is start here and go right through that point. Just like that. Now what you'll notice is these light rays are not going to meet, okay? So a lot of times kids will get stuck here because they're like, oh, I don't know what to do now. But gosh, it looks like they're not going to meet. You're right, they're not going to meet. Well, what happened last time we saw light rays that weren't going to meet? That was up here. These light rays weren't going to meet. So what did we do? We looked back at where they appeared to be coming from, right? Here's some light rays that aren't going to meet. So let's look back to see where they appear to be coming from. Well, so this light ray, if we trace them back, right, it looks like it came from, let's just continue the line back. So again, if you were looking back through this lens at the object, this light ray is unimpeded. So your eyeball would believe the top of the image is somewhere along this line. No problem. That one just goes straight through. This one, though, this is where the lens kind of fakes you out. If your little eyeball was back here looking, right, you would assume that the top of the arrow is somewhere along this line because that's where the light ray that hits you in the eye is coming from along that line. And so what ends up happening is if you trace this line back, let me get the angle correct. What you'll see is those light rays appear to meet right about here. Okay, so instead of that tip of the arrow, light rays from the tip of the arrow get bent around as though they're coming from here instead of here. So you end up, so this is your classic magnifying glass. What would happen is you would see a, again, upright, because it's the same orientation as the object, in virtual image. And the reason it's virtual here is, again, that the light never actually goes there. It just looks like it does. It appears to come from there, but no physical light beams coming off of this thing actually converge at that place. They just look like they do. So there's your upright virtual image. Again, classic magnifying glass configuration. That's the same lens as this one up above. It's just that the object, instead of being placed within the focal length, it was placed outside for this top picture. For this picture, the object is within the focal length, and that's how you get to you get the upright virtual image. You get the magnifying glass type effect. And then let's just finish this off with this last one. Just for the sake of time, I'm just going to freehand it, but I think I can do it pretty well. So light ray comes in, middle of the lens. We got ourselves a diverging lens this time. It's one of the ones that's skinny in the middle. So it's going to bend, it's going to diverge away from the optical axis here. It's going to get kicked up. And then it's like, well, how do I know how far it gets kicked up? It's going to get kicked up as though it had come from this focal point. So it's going to go tearing off like this. So there's that light ray. And then the other light ray that we always get to use is one that comes from, through the center of the lens and is undeviated. So we can do that one. So then you get yet another of these cases where it's like, gosh, this light ray and this light ray don't look like they're going to meet. They're not. And so then it's like, well, but they look like they were originating from this point. So you get another upright virtual image. So I'll put that upright virtual image. That's this guy right there. Right? So that was the original object, and you get this upright virtual image. The reason I had you go through all these cases is these are all of the possibilities if you have only one lens. This is an object outside. This is an object outside the focal length of a converging lens. This is an object outside the focal length of a diverging lens. And then there's the same two cases with it inside. One thing to notice is the only time you get the real image with one bit of optics is this very top case where you have the converging lens with the object outside the focal length. That's the only one that results in the real image.